In 1987 at King's Cross Station, a tragedy occurred where 31 people lost their lives to a fire caused by a discarded match. The way the fire behaved was new in fire investigation. Now known as the trench effect, it created a fireball that engulfed the ticket hall. The inquiry which followed this tragic event discovered that an acrid black smoke filled the ticket hall, impeding people's escape, and when breathed in, created respiratory problems and swelling in the throat due to the acidic nature of the fumes. It was later determined that these fumes were given off by the cables installed. Polyvinyl chloride or PVC, and also vulcanized Indian rubber or VIR cables. The London Underground from this point changed their installation of cable practices, specifying that only low smoke and zero fume cable is to be used on the Underground network. In this series of videos made in association with Doncaster Cables, we will be exploring a range of topics relating to cable types, cable codes, the different materials used for cable, the current carrying capacities of different cables, and the separation of cables and departures. And don't forget, this video is one in a series of videos that we have made in association with Doncaster Cables. They can be viewed individually, or you can watch them as part of a free training package to help you with your CPD and get a certificate to prove you've completed the course. When we price up a job, what is the customer's first thought? If you said, how much? Then you're probably right. The cost of materials is normally the first thing a customer will think of. And many customers want top quality products like this for prices like this. We all know that you get what you pay for, and when it comes to electrical accessories, it's no different. That's why when I spec jobs, I'm ensuring that the products I use conform to the highest of standards. So why is it when we think about cable, we just don't think the same way? Or is that just me? So why do we put such little thought into our cables? I mean, I've heard several times today from electricians that, well, it's just cable, isn't it? But is it just cable? Let's have a look at these two examples here. On paper, they both look exactly the same, and they both have a British standard number assigned to them. So we should be comfortable using them, right? Well, this standard number, EN 50525-2-1, just tells us that it's a PVC cable and PVC sheathed, but that's it. It doesn't tell us anything else, like, will it survive in a fire? Will it produce smoke when it's burnt? Will it release harmful toxic gases? You get the picture. So there seems to be more to this cabling stuff than meets the eye. So let's head down to Doncaster Cables to see how they make their cable and the standards that they're expected to be made to. Is this perhaps the most commonly used cable in the electrical industry? That's right, Twin and Earth cable. Oh, Carl! Sorry, Twin and CPC. I mean, does it really matter? Yes, it's a circuit protective conductor inside the insulation, but ever since Gary and Gordon were planting bulbs in the ground, it's been known as Twin and Earth. But I will do my best. Well, if you're more commercial and industrial, then perhaps not. But for those who rewire houses and work on domestic, then this cable is a staple for most fans. It's made using annealed copper and wrapped in PVC insulation, then wrapped further in PVC sheathing. It is a versatile and hardy cable, able to operate at temperatures at minus 15 degrees Celsius with a maximum operating temperature of 70 degrees Celsius. In the next video, I will go into more detail on operating temperatures of cables, so be sure to go on for that. And the cable comes in many different sizes, from 1mm squared all the way up to 60mm squared. The conductor cores are solid, up to 2.5mm squared. And then they step up to stranded cores up to the maximum size of 16mm squared. You will find 7 individual strands in the larger Twin and Earth cable. Oh, Carl! This allows the larger cable to be more flexible and not be prone to internal breakages when manoeuvred or bent into position. We get single cores up to 3 cores with the harmonised colours brown, blue, black and grey. And look at this cable. The CPC has got its own layer of insulation, meaning we don't have to sleeve it. An insulation revolutionary solution brought to us by Doncaster Cables. I'll be looking at this cable in more detail in a later video in this series. Single core cables are made to a very similar standard to Twin and Earth cables. Oh, Carl! Sorry, Twin and CPC. We can get a single core cable with a CPC, like the one shown here. And it was common practice back in the day to use these cables for switch wires or running in a neutral to a fitting. But the most common type to have no circuit protective conductor are these, the 6181Y cables. They have 2 layers of insulation, and this is to provide basic protection from the conductor and a final wrap of PVC insulation to provide mechanical protection. And that's it. So where do we tend to find these cables? Well, on pretty much every single incoming electrical supply, as we tend to use this cable for meter tails. These cables need to be made to BS 6004 and have the same operating temperature as the Twin and Earth. Oh, cool! The biggest difference with this cable is the size we can get it in. Sizes can start from 1mm squared and move all the way up to 35mm squared. Single core conduit cables made to BSEN 50525 with the product code 6491X are the favourite for all those conduit installers and trunking layers. Easy to install and with the added benefit of being able to run multiple circuits in a well-contained run as long as the conduit and trunking capacities have been calculated. Being single insulated, it does need to have additional mechanical protection, which comes in the form of conduit trunking or any other accessory. Single core conduit cables have a maximum operating temperature of 70 degrees. This is why we need to take great care when installing in containment systems with lots of current carrying cables all grouped together, as this will create excessive heat and could push that single core cable close to or beyond its maximum operating temperature. This could result in the failure of the cable, and it's not the cable's fault, it's the way it's been installed. So be sure to not overfill your containment systems. I remember as an apprentice spending time in the panel shop wiring motors, starters, with my electrician telling me I had to use tri-rated cable and, rather embarrassingly, not knowing what the difference was. Tri-rated cable is similar to single core and could be easily mistaken. It's only when we strip it back do we see the difference in the strands. Tri-rated has a lot more strands in it than the same singles equivalent. It also has a different insulation composition, allowing it to operate at much higher temperatures, which, if we consider all the electrical equipment, drivers and components in some of these panels, which will all give off heat, make this the perfect cable for operating under those tough conditions. And with the multiple strands, it is incredibly flexible for the tightest of control panels or motor switchgear. But why is it called tri-rated? Well, this is because this cable conforms to 3 different standards: Canada, the United States of America and the United Kingdom. This means that manufacturers who make switchgear or control panels can import and export and know that the cables are all manufactured to the standards required. When you're wanting to supply power to a unit, which could be some distance from the main consumer unit, we have a number of choices. Overhead on catenary wires, clip direct along a wall, or buried underground. The underground option tends to be the better option, as the risk of accidental snagging or mechanical strike is a lot less. Yes, of course, there's a risk of buried cables being struck, but as long as the correct procedures are followed, which includes ducting, tape, and the correct substrates, we can warn any would-be garden enthusiast from striking the cable. The conductor is a Class 2 stranded copper with a thermosetted cross-linked polyethylene insulation. It is embedded into a polymetric material, then wound in a steel armoured case. Finally, it's fully sheathed in a PVC jacket. The insulation of the armoured cable is made of a material called cross-linked polyethylene, or XLPE. But what is the difference between XLPE and your standard PVC? XLPE stands out for its superior temperature resistance, able to withstand up to 90 degrees Celsius, making it ideal for a more challenging environment. This durability leads to a longer lifespan and enhanced reliability for power cables. On the other hand, PVC is recognised for its flexibility and ease of installation, alongside having a good resistance to moisture and chemicals. However, it operates optimally within a temperature range of up to 70 degrees Celsius. The choice between XLPE and PVC largely depends on the specific requirements of the electrical system, including current carrying capacities, environmental exposure and budget constraints. FireSure 500 from Doncaster Cables is a truly remarkable cable. Let's think about where we tend to find high performance cables like the FireSure. It normally runs separate from normal power cables, perhaps in its own trunking or on tray. Fire performance cables are required to be the last operating cable in the event of a fire, as they could be providing power to a fire alarm system, centrally supplied emergency lighting, or essential electrical equipment. So it needs to be able to withstand excessive temperatures whilst also providing power to essential equipment. Don't let this number fool you, as it's the operating temperature of the cable, meaning it can work up to 70 degrees Celsius. In fact, one of the tests this cable is put through is it is tested to operate for 3 hours at 950 degrees Celsius. That it's resistant from water spray, which would likely come from a firefighter's hose, resistant against mechanical shock and impact in the event of a fire, and more. So it's safe to say this cable will stand up to the most challenging of situations. What's more is that this cable, if it was to be in a fire, the level of smoke and fumes emitted are either none or very low, and we'll be discussing the emissions of fumes and smoke in a later video in this series. The last cable from the general wiring range of cables we will be looking at is flexible cable, perhaps the most common cable type used in the world, used on appliances, hand tools, fridges, vacuum cleaners, well, everywhere. This can create issues, certainly when we consider where we potentially purchase appliances from. Cheaper imported cable has been on the rise in recent years, but do these cables meet the high standards that are required for the British market? Well, possibly not. If we take this flexible cable as an example, it is used predominantly in handheld appliances and portable equipment and comes with the relevant standards for this cable and a harmonisation code, so we know it can be used in countries harmonised with our standard. The EN 50525-2-11 standard is concerned with PVC insulated and sheathed flexible cables, including both circular and flat varieties, and sets out comprehensive guidance on the safe usage and the rigorous testing required for the cable to be used. However, this cable, which looks identical, does not meet the same standard, even though it says so here. This brings us nicely to standard. We will be discussing in more detail in the next video the different standards and harmonised cable codes, but a common misconception with cables is that they are all made to the same standard, and this just isn't the case. In the next video, we will be looking at harmonised cable coding and their meanings. But remember that this video is one of a series of videos that we've made in association with Doncaster Cables. They can be viewed individually, or you can watch them as part of a free online training package and receive a certificate to prove you've completed the course. But until then, it's bye-bye for now.